Okay, this is for Physics 6C. This is my Pencast. This is homework number 42. The problem is a 2 nanocoulomb charge is at the origin and a negative 4 nanocoulomb charge is at x equals 1 centimeters. So the first half of the question is A, what x coordinate could you place a proton at so that it would experience no net force? And part B is, would the net force be 0 for an electron at the same position? So I already drew out a couple of things that we're going to need to go through just to save some time. And first we're going to look at the graph and plot our coordinates. So we were given charge 1 is 2 nanocoulombs, and it's at the origin. And then charge 2, or Q2, is negative 4 nanocoulombs, and it's at x equals 1 centimeter. So P is going to stand for our probe. R is this distance right here, which is 1 centimeter. And x is going to be wherever our probe is being placed. So that's our unknown. The equation that we're going to use is for force, because we're going to be equating forces. And there's that constant for K. So the big problem with this question is where to put the probe. And it's not instantaneously obvious. You really have three choices. You got left, middle, and right. And Q2 is negative 4. So the right's not really a good option because the odds are, since the force is dependent on distance, this force is generally going to win compared to this force, which is weaker. So right's not really a good option. Middle, you've got a positive and negative, and again, this force is much greater, or this charge is much greater than this charge. So middle doesn't really work either. Left is going to be the best place to start looking for the probe. So somewhere out here. So now how to calculate this? Basically, we're looking for a place where there's no net force. Another way of saying that is that we want the forces acting on the probe to equal each other, or basically equaling 0. So I'm going to write that out as two equations. The first equation is going to be K, absolute value Q1, times the absolute value of the probe, divided by x squared, because again, location based off of the left of Q1 of the probe. And that's going to equal K Q2 probe. But here the distance value is different because we're going from Q2 to the left. So we need to add this 1 centimeter of distance. So I'm going to do that by saying this is x and this is 1 centimeter. So that'll be x plus 1 squared. So then we're going to cancel out like things, like terms go away. You'll notice that the probe cancels. You get absolute value of Q1 over x squared is equal to the absolute value of Q2 over x plus 1 squared. Okay, so at this point we're going to go ahead and plug in for those charges. So 2 nanocoulombs over here for x squared is equal to, and its absolute value, so it's just going to be 4 nanocoulombs. We're not going to bring that negative charge in, over x plus 1 squared. And then we're going to cross multiply. Actually, before I do that, I'm going to go ahead and divide by 2 just to simplify things. So that brings this to 1 nanocoulomb over x squared is equal to 2 nanocoulombs over x plus 1 squared I'm going to go up here, cross multiply, x plus 1 squared is equal to 2x squared. If we expand that, you're going to get, let's see, x plus 1 times x plus 1 equals 2x squared. It's going to be x squared plus 2x plus 1 is equal to 2x squared. We subtract the 2x squared from both sides. That's going to give us negative x squared plus 2x plus 1 equals 0. So we have a quadratic, and that means we're going to use the quadratic equation. And so that's x equals negative b plus minus square root b squared minus 4ac over 2a. And so you plug in, you get negative 2 plus or minus negative 2 squared minus 4 negative 1 1 2 negative 1. So if you simplify this, you're going to end up with two results. One of those results, and I have to work up here, actually let's work over here. Say results is going to be 1 plus square root of 2, and 1 is going to be 1 minus square root of 2. So we can use one of these and we can't use the other. This is the one that we can use. What this result says, and it's actually equal, if you plug it into a calculator, you'll get about 2.41. And we're in centimeters because that's our unit of distance that we're using here. Basically what this is saying is that because we're looking at this distance in respect to Q1, remember x and Q1 are linked here. That's how we defined our original conditions. It's 2.41 centimeters on the left of it. So our probe is going to be, if we say this is 1 centimeter, approximately here. So 2.4 is going to be somewhere out here. That's our probe. This gives you a negative value, which places you in between the probes, which because we said that Q2 overwhelms Q1 in this middle space, you can't really have it there. So that's a no-go. So that's part one of this problem. Part B again was, would the net force be 0 for an electron at the same position? And we don't actually have to do any math for that. We can go ahead and just say yes. And that's just based off of this equation here. So whenever we're working for this force, we're always working in absolute values. So it doesn't really matter if we were to change P down here to be positive or negative, A, because it cancels, and B, because even if it was there and we could plug it in, it would just be the absolute of that charge. So if it was negative 4, it'd be 4. If it was positive 4, it'd still be 4. So yes, for this point P, the net force would be 0 also for an electron. Thanks for listening to my problem, and I hope you're having a good one, or a good day. Bye.